we often hear about the endless size of the universe, but have you ever wondered how it actually looks when viewed on the largest possible scales? When we look at the night sky, it might seem like stars and galaxies are scattered randomly, but when we zoom out sufficiently, a striking pattern emerges. The universe is not random, it is organized into a giant network that we know as the large-scale structure. This vast web is made out of enormous clusters that are massive groups containing hundreds or even thousands of galaxies bound together by gravity. These clusters are linked by long, thin threads called filaments, which are packed with galaxies and clouds of gas stretching like bridges between the clusters. Between these filaments and clusters lie vast empty spaces called voids. These voids are unimaginably large regions of the universe where there is very little matter, just a few atoms scattered across enormous distances. To understand the scales of these structures, we measure distances in megaparsecs. 1 megaparsec is about 31 trillion kilometers, meaning 1 with 12 zeros. In these units, we would need 33,000 samples of our galaxy, the Milky Way, placed side by side to account for only 1 megaparsec. The filaments of this cosmic web can stretch across hundreds of megaparsecs, connecting galaxy clusters that themselves span tens of megaparsecs. The voids between them can be even larger, making the cosmic web the most massive structure in the universe. This structure is not just made out of the matter that we can see, meaning stars, galaxies, and gas. Most of it is held together by something invisible that we call dark matter. Dark matter doesn't emit or reflect light, hence the name. We cannot see it directly, but we know it is there because of its effects on galaxies and the matter that we do see. It pulls on galaxies and helps hold this web together. Without dark matter, this complex structure wouldn't exist. This isn't just theory. Even though we can't directly see this web, the community has uncovered its shape by observing and mapping galaxies and the faint glow of the gas found in the empty spaces between them, revealing its incredible patterns. Think of it like looking at the lit-up system in a highway at night. The galaxies are the bright lights tracing the invisible roads of the universe. To compare the observations with our theories, we also use computer simulations based on the laws of physics, so that we can recreate, at least to some extent, this web and match it to the data. You may be wondering, how did this cosmic web form? It all starts with gravity. After the Big Bang, tiny fluctuations in the density of matter began to grow under the pull of gravity. Over billions of years, these denser regions became the filaments and the clusters that we see today, while the emptier regions turned into the cosmic voids we mentioned, areas almost entirely empty. The cosmic web is more than just a pretty pattern. It's the backbone of the universe. It connects everything from the tiniest star to the largest galaxy cluster, reminding us that even in the vastness of space, everything is interconnected.